Hello, my name is Cecilia Reed, and this is my second lab report for Physics 2212 regarding the buildup of charge on everyday objects. The purpose of this lab is to determine the excess buildup of charge on Scotch tape and to observe the behavior of charged products with a more accurate model. I first went through Lab 1, then fit the experiment to an updated GlowScript model. The new net charge on the tapes with the line charge model was 2.26141 times 10 to the negative 8th, a whopping 242.3% higher than what was calculated in Lab 1. The major concepts present in this experiment which allowed us to calculate the results were Coulomb's law, the definition of an electric field, force on a charged object, Newton's second law, and force due to gravity on an object, exactly as they were in Lab 1. One can see that exactly like experiment 1, F net is equal to 0 for this experiment. The electric and gravitational forces are equal and opposite to each other, which can be plugged into other equations to find the charge of the tapes. The principle of like charges repelling was integral to this lab again because it allowed us to determine the charge of the U-tape by observing its behavior near known charges. To begin the experiment, I measured out one piece of tape that was 0.2 meters long. I created a little handle at the end for ease of cleaning and stuck it to a desk. I then measured out an identical tape and created a handle and stuck it on the other tape. I quickly ripped the top tape, called the U-tape, off in order to charge it. I repeated the same process in order to create a second U-tape. I tested to see if the U-tapes were charged by holding them near my hand, which is a neutral object. I held the two U-tapes towards one another to make sure they were still charged, and I charged a plastic pen by rubbing it on my hair and held the U-tapes up to determine if it was positively or negatively charged. Finally, I placed one of the U-tapes between two tables and began to slowly move the other U-tape closer to it. I stopped when the top U-tape began to float and measured the distance. This particular part of the experiment allowed us to calculate the excess charge on the tapes. First, we had to make some assumptions to simplify our calculations, which is where Lab 2 starts to diverge from Lab 1. For the calculations, I assumed that each U-tape had the same net charge and also that charge was evenly distributed across the tape. The observations that I made during the lab were that the U-tapes were attracted to neutral objects like my hand and that they repelled each other, indicating that they have the same charge. The U-tape was also attracted to the negatively charged pen, indicating again that it is positively charged. I observed that they began to float at 0.02 meters apart. Next, I performed my calculations starting with the gravitational force, which is equal to the electric force in the y direction. This allows us to solve for Q by plugging in the numbers we have, and a force of gravity came out to be 1.6 times 10 to the negative 3 newtons. I used this GlowScript code to model my experiment. The function used to calculate electric field was lifted directly from Lab 0, which I copy and pasted into the respective area. I edited the position of top tape and bottom tape to reflect its real-life counterparts by setting the top tape D distance for 0.20 meters away in the y direction. I calculated E at DQ top by adding that to DE at DQ top by DQ bottom, which updated every time it ran through the for loop. There was a strange error that occurred when I attempted to use the charge estimation from Lab 1, indicating that it is not as accurate as we would have hoped. I managed to find that the real charge is closer to 2.26141 times 10 to the negative 8th coulombs rather than what was calculated at 9.3 times 10 to the negative 9th coulombs. Inputting 2.26141 times 10 to the negative 8th coulombs instead of our original estimate yielded a more accurate model of charge interaction and also allowed Fe to match Fg. Here are the comparisons of Lab 1 compared to Lab 2. Lab 2 follows the line charge model, while Lab 1 treats each tape as a point charge, yielding drastically different results. Here are the representations side by side. What if you had modeled each of your tapes as a single point charge, like in the previous lab? If we were to model the tapes as point charges, as we did in Lab 1, the charge estimate would come out to be 9.33 times 10 to the negative 9th, as opposed to the value 2.26141 times 10 to the negative 8th coulombs. This difference comes from the difference in treating the models as points versus treating it as a line charge. The difference between these two values, as previously noted, was a staggering 242.3%. Why did these estimates differ? They differ because they treat the charges differently, and the line charge estimate should be closer to the real value than the point charge. This is because in reality, the tape's charge is spread out all over the surface of the tape rather than concentrated into a single point mass. The model that more closely resembles this is Lab 2's model, or the line charge model. The charge on the tape should be around 2.2614 times 10 to the negative 8th coulombs. Thank you for listening.